Alright, let's take a look at the difference amplifier, also known as differential amplifier, differential, and also known as the subtractor. Okay, so this is the difference amplifier. So this amplifier, what it does, it amplifies the difference between two inputs. So let's go ahead and define that here. But the key thing to it, it also rejects any signals that are common to the two inputs. So let's go ahead and define this. So a difference amplifier is a device that amplifies the difference between two inputs but it rejects any signals common to the two inputs. But rejects any signals common to the two inputs. Okay. So let's take a look at this this amplifier here, this configuration. One thing you want to note is that we have zero currents going in, into the op amp. Okay, and so by making that observation, we can apply KCL. So apply KCL at node A, and then we see that we got V1, voltage 1 here, minus VA over R1, V1 minus VA over R1 is equal to VA minus V output over R2, and R2 is our feedback resistance. So the current coming in here equals the current going out of there. Okay, so VA minus V out over that feedback resistance R2. Okay, we can rearrange this equation. Say V naught equals R2 over R1 plus 1 times VA minus R2 over R1 times V1. Okay, so if we just rearrange that equation, we get V out is that. So let's go ahead and just highlight this equation here. And now let's apply KCL. Up a little bit. Apply KCL at node B. Okay. Here we got B2 minus VB over R3. I'm gonna write that down. V2 minus VB over R3, alright, equals VB minus 0 over R4. Okay, again, we have current going in, current coming out. And then we can rearrange this in terms of, in this case, we got VB. Let's go ahead and rearrange it in terms of VB. And then we get, scroll up just a little bit, VB equals R4 over R3 plus R4 times V2. Okay. But remember, VA equals VB. Alright, so we can substitute, so this is really also VA. So substitute that here. Okay, so we can substitute this back into VA over here and rearrange the equation. So let's go ahead and do that on the side here. We plug in that equation that we just came up with into this equation in the blue square, and I'm going to rewrite this. So V naught equals R2 over R1 plus 1, and then this is where we're going to substitute the VA, which we said was R4 over R3 plus R4 times V2 minus R2 over R1 times V1. We can rearrange this a little bit more if you wanted to, and we can rewrite it as V naught equals R2 times 1 plus R1 over R2, and then we got in the denominator R1 1 plus R3 over R4, all that times V2 minus R2 over R1 V1. So let's highlight this equation. So this is what we're getting for the difference amplifier. Okay. So as we mentioned, since this difference amplifier, it has to reject the common signal to the two inputs. Okay. Then this amplifier must have a property that such that V naught equals 0 when V1 equals V2. Okay, and this exists. So let me go and write this down. Since difference amplifier or amp must reject a signal common to the two inputs, the amplifier must have this property. So this property is this guy here. Okay. And this exists when R1 over R2 equals R3 over R4. So when the op amp is a difference amplifier, it becomes, so when op amp is a difference amplifier, becomes V naught equals R2 over R1 times V2 minus V1. Furthermore, if R2 equals R1 and R3 equals R4, this difference amplifier becomes a subtractor. The difference amplifier becomes a subtractor. Okay, so meaning V0 is going to equal to V2 minus V1. So let's go ahead. We have a couple of equations here we want to highlight. This guy. And there's this one. Okay, so when we have a difference amplifier here, and then we have a subtractor here. Alright. So that's the definition of, let's scroll back up, a difference amplifier or differential or subtractor. Okay. We did basic KCL across node A and B to come up with this equation. Because we want to reject the common signals between the two inputs, we can further simplify this equation, and then we can get the difference amplifier equation of this guy here. And if R2 is equal to R1 and R3 is equal to R4, then the difference amplifier becomes a subtractor, and we simply have V out is just V2 minus V1.